Welcome to Meteorology Matters, the show where we really try to unpack complex topics and give you the essential insights. Today, we're diving into something that honestly sounds a bit wild at first. What on earth do sharks, some of the ocean's top predators, have to do with predicting, say, the next big hurricane?
It sounds almost like science fiction, doesn't it?
It really does. But we're exploring this incredible connection between sharks and severe weather today. And hopefully by the end, you'll see both these, forces of nature a little differently.
Absolutely. And what's really interesting, is that while this feels super cutting edge, maybe even brand new, scientists have actually been thinking about how marine life and big storms interact for quite a while.
Oh, really? So it's not totally out of the blue.
Not entirely. I mean, some of the really foundational work in this area, it comes from top places, like the University of Miami's Rosenstiel School of Marine and Atmospheric Science. They've been looking into this ocean atmosphere dance for ages.
Rosenstiel. Okay. I know that name.
Yeah, it's a big deal in marine and atmospheric science. And it's interesting context for listeners who follow the field closely. Meteorologist Rob Jones, whose insights we often draw on. He actually went to school there and worked there previously too.
No kidding.
Yeah, so he's got this, unique perspective on exactly this kind of marine and atmospheric interaction. It just underlines that the shark research, it isn't some random tangent. It's more like an exciting evolution of questions scientists have been asking for a long time.
That really sets the scene perfectly. So our mission today is to explore these, surprising shark behaviors during hurricanes. And maybe more importantly, how these amazing creatures might actually help us get better at forecasting the weather. You probably think you know sharks, right? And you definitely know hurricanes. But what happens when they collide? Get ready for some moments that might make you go, huh? Because these predators aren't just surviving storms, they might be teaching us about them. We want you to get the knowledge quickly, but, thoroughly. Lots of cool facts along the way. So let's zoom in then. How do these animals sense a storm coming? How do they react? For a long time, the thinking was pretty simple, wasn't it?
Yeah, the general idea, mostly from studying smaller shark species, was pretty straightforward. Big storm coming, sharks leave, get out of the way.
Makes sense. Seems like the smart thing to do.
Right, basic survival instinct.
Yeah.
But there was this, big gap in what we knew about the large sharks, the apex predators.
You mean like tiger sharks, bull sharks?
Exactly. Tiger sharks, bull sharks, hammerheads. These guys are at the top of the food chain. What they do, it really affects the whole ecosystem. So knowing how they handle a massive storm is, it's pretty crucial, especially now with climate change potentially making storms more intense.
So what did the newer research find? Did they leave too?
Well, that's where it gets complicated and really fascinating. Recent studies show a much more complex picture. Some large species do clear out, yeah, but others, they surprisingly stay put. Or, even weirder, they sometimes swarm after the storm.
Swarm, like more of them show up.
Exactly. It totally challenged those older, simpler ideas.
Okay, you've got to give us an example. That sounds wild.
Okay, so the big one, the real eye-opener, was Hurricane Matthew back in 2016.
Oh yeah, Matthew was a monster. Category 5.
A total monster. Over 140 mile-per-hour winds. And it made basically a direct hit on a research area in the Bahamas where scientists already had sharks tagged and were monitoring them.
Wow, talking about timing. Unplanned, but perfect for research.
Incredible, right? A real-world test, intense as it gets. They had this network of underwater receivers listening for the tags on the sharks.
So what happened? Did the tiger sharks bolt?
That's what everyone expected. But no. The study showed that during the hurricane, the number of tiger sharks in that specific area stayed steady. They just stayed. One researcher said they didn't even flinch.
Against a Cat 5, seriously.
Seriously. Which was, totally different from what they'd seen with smaller sharks. But then the really mind-blowing part happened after the storm passed.
Okay.
In the days after landfall. The number of tiger sharks they detected in that area doubled.
Doubled. Hold on, why? Why would more sharks show up after a devastating hurricane? That seems completely backward.
Right, it does. But the main hypothesis, the leading theory, is scavenging.
Scavenging, you mean?
Think about it. A storm like Matthew, sadly, it kills a lot of marine life. Fish get stunned, turtles get injured, things get churned up and die. For an opportunistic predator like a tiger shark.
It's basically a buffet.
Exactly. A sudden, massive abundance of easy food. So instead of fleeing the chaos, they might actually be drawn to the aftermath, to the feeding opportunities. It's a totally different survival strategy compared to the smaller sharks who probably couldn't capitalize on that the same way, or the risk is just too high.
So tiger sharks are like the ocean's cleanup crew after a disaster.
Kind of, yeah. It raises all these new questions about how different species adapt their specific roles. It's not just about running away. Sometimes it's about exploiting the chaos.
Fascinating. Okay, so that was Matthew and the tiger sharks. But you mentioned other species reacted differently.
Yeah, fast forward just 1 year, September 2017, Hurricane Irma.
Another big one.
Definitely. It passed northwest of a different research site, this one in Biscayne Bay, Florida. Now, Irma wasn't quite as strong as Matthew at that point when it passed Biscayne Bay, but it still brought significant wind, waves, and crucially, that big drop in barometric pressure.
And what did the sharks there do?
Well, this time, the researchers were tracking nurse sharks, bull sharks, and hammerheads. And these guys, they all left. They cleared out before the storm really hit the area.
Ah, okay. So that fits the older model more, fleeing the danger.
It does. That behavior wasn't totally shocking based on what we knew. But seeing that compared to the tiger sharks sticking around through a Cat 5, that comparison really highlighted the difference. It made researchers ask, are some sharks actually attracted to storm zones? Can they track the storm's path somehow?
Using those senses we talked about.
Maybe. Using their inner ear, their lateral line. Maybe it's more sophisticated than just pressure dropping, time to go. Maybe they can sense the direction, the potential for that post-storm buffet. It's clear not all sharks react the same way. Their responses are really varied.
Okay, so let's dig into that sensing part more. How do they know? You mentioned barometric pressure. People sometimes say they feel storms in their joints, but sharks have something more refined.
Oh, way more refined. It's a good analogy, though, the feeling it in your bones. To get it, think about the air around us. We're basically at the bottom of an ocean of air, right? The atmosphere.
Right.
Barometric pressure or atmospheric pressure is just the weight of all that air pressing down. At sea level, more air above you, higher pressure. Go up a mountain, less air, lower pressure.
Simple enough. And hurricanes.
Hurricanes need fuel. Two main things. Really warm ocean water, like at least 80 degrees Fahrenheit in the top layer, maybe 150, 160 feet deep, and the right wind conditions. When that warm, moist air rises super fast off the ocean.
It creates low pressure.
Exactly. A rapid drop in pressure at the surface, especially in the eye of the storm. That sudden change, that pressure gradient, that's the key signal for marine life. It's like a giant, something big is happening, sign flashing in their environment.
So it's not just the waves getting rough, it's this fundamental pressure shift they feel.
Precisely. Long before the worst waves hit, that pressure starts to plummet. And sharks, well, they're exquisitely attuned to it.
How? What parts of their body are picking this up?
Two main systems are thought to be key. First, their inner ear. It's hidden behind those little holes on the sides of their head. It's not just for hearing sound in the way we think of it.
Okay.
It's lined with these incredibly sensitive sensory hair cells. Scientists are pretty sure these cells can detect those subtle but significant changes in pressure, like tiny biological barometers constantly monitoring the weight of the water and air above.
Wow. And the second system, you mentioned the lateral line.
Yeah, the lateral line. You can sometimes even see it, like a faint line running down their body. It's basically a tube filled with sensory cells that detects water movement and pressure changes right next to their skin.
So that helps them find prey in murky water.
Right, by feeling the water pushed aside by a fish. But it likely also helps them feel the bigger pressure waves and turbulence caused by a storm building up or passing over. It's like having sensors all along your body complementing what the inner ear detects. It gives them this 3D picture of the pressure environment.
An incredible toolkit. And they really need it, don't they? Because it's not just windy topside during a hurricane. Underwater must be chaos.
Absolute chaos. It's hard to even imagine. We see the damage on land, but underwater, you can get waves 60 feet high. 60 feet. And these create powerful surges, underwater currents that can go down hundreds of feet. Maybe 300 feet deep.
300 feet. That's immense force.
It is. Enough to rip up coral reefs, stir up sediment, completely change the underwater landscape. And it's not just the physical force. Storms churn the water, mixing deep, cold, low-oxygen water with the warmer surface water.
So oxygen levels drop. Salinity changes.
Dramatically. You can get areas that become hypoxic, meaning very low oxygen, or even anoxic, no oxygen at all, lethal for most marine life. Plus, that sudden temperature change from upwelling can shock animals. So for a shark, being able to sense the storm coming isn't just convenient,
It's survival.
it's absolutely critical. They have to read the signs and react fast. Get out, or hunker down, or maybe even like the tiger sharks, prepare to exploit the aftermath. They don't have weather apps. They have biology honed over millions of years.
It really puts our technology in perspective sometimes. Okay, so doing this kind of research, tracking these animals through hurricanes, it sounds incredibly difficult. How rigorous is this science?
Oh, incredibly. The preparation alone is immense. Just finding and catching enough sharks to get a decent sample size, that's a huge challenge right there.
How many did they tag in those studies you mentioned?
In the Bahamas and Florida studies looking at Matthew and Irma over a 3-year period, the team managed to tag 98 sharks, almost 100 individuals.
98. Wow. And how do they catch them safely?
Mostly using specialized fishing lines, often circle hooks, which are designed to hook the shark in the jaw, minimizing injury rather than being swallowed. Then they bring them carefully alongside the boat or onto a submerged platform.
And the tagging is quick.
Very quick. The teams are highly skilled. They work fast to attach the tag, usually to the dorsal fin, take measurements, maybe a small tissue sample, and get the shark back in the water, often in just a few minutes to minimize stress. It's a very controlled, careful procedure.
Okay, so the shark is tagged. How do they follow it across, the entire ocean?
That's where the technology comes in. They use acoustic telemetry networks. Think of it like an underwater listening grid.
Listening grid.
Yeah. They anchor these acoustic receivers, dozens of them, to the ocean floor in strategic locations. In the Florida and Bahamas studies, they put out 64 receivers between 2014 and 2016.
Okay.
And the tags on the sharks, they emit a unique acoustic signal, like a little ping. When a tagged shark swims within range of a receiver, maybe half a mile or so, the receiver logs the shark's ID number, the date, and the time.
Ah, so they build up a picture of movement by seeing which receivers pick up which sharks and when.
Exactly. By retrieving the data from these receivers, sometimes divers go down, sometimes they use remote methods. They can map out where the sharks were and when, especially before, during, and after storms like Matthew and Irma passed through those specific areas.
That's ingenious. And all this tracking, all this data, what did it tell us beyond some stay, some go? What bigger questions came out of it?
Well, like we touched on, it really forced scientists to ask why the difference is. Is it just about food for the tiger sharks? Or is there something else drawing them to storm zones? Are they really tracking the storms actively?
Using those senses.
Potentially. Could their lateral lines and inner ears be sophisticated enough not just to sense pressure drop here, but to follow the path, maybe anticipate where the storm is going or where the aftermath, the scavenging will be best? We don't know for sure yet.
So many questions still.
So many. But the big takeaway is just how diverse and complex their responses are. Some species are incredibly tough, unfazed by massive storms. It just shows our understanding of these ocean ecosystems is still very much a work in progress. There's so much more to learn.
Which leads perfectly into this next part, this idea of sharks as meteorological allies.
Yeah.
That sounds like a leap, but given the challenges in forecasting.
It is a leap, but maybe a necessary one. Look, meteorologists have amazing tools, satellites, buoys, computer models, but the ocean is vast. And getting temperature readings below the surface, especially across the whole Atlantic, is really, really hard.
Satellites only see the surface temperature, right?
Exactly. They can't see if there's a deep layer of warm water that could fuel a hurricane or a hidden layer of cold water that could kill it. We have robotic floats, Argo floats, and underwater gliders that can measure temperature at depth.
They're slow.
Yeah.
And sparse.
Right. They drift slowly or move slowly. They're expensive. So you end up with huge areas of the ocean, particularly in the tropics where hurricanes form, where we just don't have enough real-time data about that subsurface heat content. These are significant data gaps.
And that heat is the hurricane's fuel tank.
It's the heat engine. Knowing if a storm is about to pass over a deep pool of warm water versus cooler water is critical for intensity forecasting. Get that wrong, and your forecast for how strong the storm will be can be way off. And these gaps are worst in places like the Caribbean, the Gulf of Mexico, off the East Coast, exactly where we need the info most.
Okay, so there's a clear data problem. How do animals, specifically sharks, potentially help solve this?
Well, researchers started thinking, if the robots are too slow or too few, what about using animals that are already out there swimming through these areas constantly? Animal ocean sentinels.
Has this been done before? using animals for data collection.
Oh yeah, it's not totally brand new. Scientists have been tagging elephant seals in the Antarctic for years. Those seals dive incredibly deep in areas ships can barely reach, carrying sensors that measure temperature and salinity. Same with narwhals in the Arctic. It's provided amazing data from polar regions.
And even dolphins and whales for other purposes.
There have been reports, yeah, of some military or intelligence programs exploring using marine mammals. But for hurricane forecasting in the Atlantic, sharks have some real pluses.
Such as?
Well, many species are faster swimmers than gliders. They cover huge distances, they dive deep, they live in the hurricane breeding grounds. The idea is they could complement the existing systems, not replace forecasters or satellites, but swim through those data gaps, collecting temperature and depth readings, and beam them up when they surface.
Adding more data points to the models.
Exactly, working with the current technology to fill in the blanks.
And this is especially relevant now, you mentioned, because of potential funding issues for agencies like NOAA.
Right, the National Oceanic and Atmospheric Administration. There are always discussions about budgets, staffing levels. If resources for traditional monitoring, like maintaining buoy networks or flying hurricane hunter planes, get tight,
Then having alternative data streams becomes even more important.
crucial. It makes exploring innovative, maybe even lower cost, solutions like instrumented sharks not just scientifically interesting, but potentially really vital for maintaining or even improving our forecasting ability, especially in a changing climate. It's about resilience, finding multiple ways to get the information we need.
Okay, so the concept is powerful, but the logistics. How do you actually catch something like a mako shark and attach a sophisticated sensor? What's that process like?
It's definitely not trivial. The teams doing this are incredibly skilled. They usually head way offshore, like 40 or 50 miles. They use bait, big chunks of fish, and also chum.
Like in Jaws.
Sort of, yeah. It's basically ground up fish parts, blood, oil. They put blocks of frozen chum in the water. As it thaws, it creates this oily, smelly trail that drifts for miles on the current. Sharks have an amazing sense of smell, and it draws them in.
Okay, so you attract them. Which species did they start with for these weather tags?
The initial focus was on short-fin makos.
Why mako specifically?
A big reason is their behavior. Makos frequently come to the surface. And that's critical because these tags need to break the surface to transmit the data they've collected, temperature, salinity, depth, via satellite back to the scientists. If the shark stays deep all the time, the data gets stuck on the tag.
Makes sense. And the tagging itself, you said it's quick.
Very quick and careful. Once the shark is alongside, the team works fast to attach the sensor package, usually to the base of the dorsal fin. They're very conscious of minimizing any harm or stress to the animal.
Which brings up the ethics, right?
Yeah.
Makos are endangered, aren't they? How do researchers justify tagging them?
That's a really important question, and the researchers are acutely aware of it. Yes, shortfin makos are endangered, mainly due to overfishing. It's a serious conservation concern. Globally, about a third of all shark and ray species are threatened.
So there's a real tension there.
There is, but the scientists involved are usually passionate conservationists themselves. They argue the data gain is vital for understanding the ocean environment sharks depend on, which ultimately helps conservation. They stress they do everything possible to minimize impact. The procedure is quick, sterile, and the tags are designed to eventually detach safely. They often say they love the animals.
And maybe this research helps change how people see sharks, too, away from the Jaws stereotype.
Absolutely. That's a huge side benefit. For 50 years since the original Jaws came out, and with movies like Sharknado and others, sharks have been painted as these mindless monsters that really hurts conservation efforts. This research shows their complexity, their resilience, their critical role, and now maybe even their potential as allies in understanding our planet. It helps people see them as valuable, important animals, not just threats.
That's a powerful point. So where does this Shark Sentinel project stand now? Is it working?
It's definitely still in the proof of concept stage, but yes, it's showing great promise. They've had success. One of the first Makos tags successfully sent back temperature data, but it's very much a learning process.
A debugging exercise, you could say.
Exactly. They're constantly refining the tags, the attachment methods, figuring out battery life, how to deal with algae growing on the sensors, ensuring the satellite uplinks work reliably. It's tough engineering in a harsh environment.
What are the plans moving forward? More sharks? Different species?
The plan is definitely ambitious. Tag dozens of sharks each year to build up a network. And yes, while makos were the starting point because they surface reliably, they're looking at other species too.
Like great whites.
Potentially. They've put a location tag on a great white already, just to track movement. Whites travel huge distances, so they're a strong candidate if they can get the temperature sensing tags to work well on them. They're also considering hammerheads, maybe even whale sharks down the road. Different species use different parts of the ocean, dive to different depths, so using a variety could give broader coverage.
And the ultimate goal for all this data they collect.
The dream is to feed it directly, in near real time, into the hurricane computer models that forecasters use, adding all those extra subsurface temperature points, especially from areas that are currently data deserts.
Should make the forecasts better.
That's the hope. More accurate intensity forecasts, maybe better track forecasts, too. As one researcher put it simply, the more data we have, the better things will be. It's about reducing the uncertainty around these incredibly powerful storms.
Well, this has been absolutely fascinating. We've really journeyed from the basic biology of how sharks sense storms to this futuristic idea of them becoming part of our weather monitoring network. We talked about how different species react, tiger sharks sticking around, maybe even benefiting from the aftermath of a Cat 5 like Matthew, while nurse, bull, and hammerheads fled Irma, likely using their amazing inner ears and lateral lines to get an early warning.
And then moving into how scientists are trying to harness that, using acoustic tags to track them, and now these more advanced satellite tags to turn sharks like makos and maybe soon others into mobile ocean monitors, filling those crucial data gaps, especially in ocean temperature beneath the surface, which is so vital for predicting hurricane strength.
So the big takeaway for you listening is just how interconnected and, frankly, how intelligent the natural world is. These relationships, like between sharks and storms, they're complex, they're vital, and understanding them is becoming more important than ever, especially as our climate changes and weather potentially becomes more extreme.
Yeah, it really underscores why we need to respect and study these animals, understand their roles. They're not just swimming out there, they're interacting with their environment in ways we're only beginning to appreciate. And sometimes they might even hold keys to helping us adapt.
Absolutely. If this deep dive has got you thinking and you want to keep exploring the world of meteorology and the connections to our natural world, we definitely encourage that. You can find great insights from meteorologists, including Rob Jones, online. You can follow meteorologist Rob Jones on Instagram. His handle is meteorologist. On TikTok, he's TV meteorologist. And over on YouTube, look for Rob Jones Hurricane. That's also where you can find the Meteorology Matters podcast playlist.
Definitely worth checking out. And it leaves you with a final thought, doesn't it? As we face these climate challenges, as our technology keeps evolving, what other natural sensors, what other biological systems might be out there waiting for us to understand them, maybe even partner with them to learn more about our planet?
Yeah. It really feels like the ocean especially still holds so many secrets. And maybe some of the most innovative solutions we need are already swimming around out there.